This be video 9-2, limiting reactants and percent yield, mateys. Okay, so limiting reactants, also sometimes called limiting reagents. A reagent's basically just a reactant. Okay, now what's a limiting reactant? It limits the amount of product that can be formed. Okay, the reason why it does that is basically it's going to get used up in the reaction. Okay, this also determines how much of the other reactant, also which is called the excess reactant, that can be used in the reaction. Okay, now sometimes this is kind of rare, but you end up with what's called stoichiometric quantities. Okay, all the reactants are used up and there is no excess reactant. Okay, it's kind of weird. It's, let's say you're making cookies or something like that, and you need a certain amount of butter, a certain amount of sugar, a certain amount of flour, things like that. Okay, and just so happened that you had the exact correct amount of everything. In other words, once you're done, you look and you go, hey, I emptied all the sugar, I emptied all the bag of flour, and all these other things. Okay, then that would be stoichiometric quantities. Usually that doesn't happen. Usually you have a big bag of sugar and you got a whole bunch left over or something like that. Okay, now, two ways you can figure out which is the limiting reactant. Okay, let's say we got a problem here. A is going to react with 2 moles of B and you get C and D. Okay, and let's say we had 30 grams of A and 10 grams of B. Okay, now, are they both going to get used up? Is one going to be left over? Okay, and if so, which one? So, how do we figure out which one is the limiting reactant? Which one gets used up? Okay, first way, figure out how much of the second reactant is needed to use up the first one. Okay, what do? Pick one of the reactants, doesn't matter. Pick either A or B. Then change it into moles. Okay, then change those moles into moles of the second reactant. Okay, then change the moles into the unit given for the second reactant. Okay, so let's go back here and figure it out what we're doing. Pick one of these. So let's take the 30 grams of A. Okay, now I need to change it into moles. Change it into moles of A. Then change it into moles of the second reactant, which means change it into moles of B. Okay, then change it into the units that you know that you're given. In other words, in this case, it's grams. So change it into grams of B. Okay, now this is the amount that you have. This is the amount that you need. Okay, so what do we do with these two numbers that you just figured out? Okay, compare the quantities. If you have this much, okay, then the first reactant is the one that's going to be used up. In other words, what we did here, we said if I have 30 grams of A, how many grams of B? Let's say this came out to be 8 grams of B. I have 10 grams. Okay, so that means if I actually have at least, if I need this much and I have at least this much, then A will be completely used up. Okay, so in other words, what you need has to be less than what you have. Okay, then A is the limiting. If it's not, then you do it the other way around. Okay, B would be the limiting. Second way, and I would suggest you do it this way. Okay, change the moles into the given unit. Whoops. Second way. Okay, figure out how much product each reactant can produce. So A plus 2B is going to yield C and D. Okay, change the given quantities. So let's say we had 30 grams of A and 10 grams of B again. Change the given quantities of each one into one of the products. Doesn't matter which one, but pick one of them. Okay, and whichever one produces the least amount of product is the limiting reactant. So I need to do two problems. I need to take 30 grams of A, change it into moles of A, then pick one of the products. So let's say we're going to pick C. So then I change it into moles of C. Okay, and you don't have to go to grams, just leave it in moles. You also have to do it for the other one. So I take the 10 grams of A, 10 grams of B, change it into moles of B, then change it into moles of C. Okay, now whichever one is smaller, produces the least amount of moles of C. That is the limiting reactant. Okay, so let's try a problem here. 15 grams of oxygen, 5 grams of hydrogen react. How many grams of product will produce, and how much excess reactant will be left over? Okay, so let's go figure out, first of all, you need to know what's the reaction. Okay, it's oxygen reacting with hydrogen. And by now you guys should know this is going to produce water. Okay, next thing, balance it. I need 2 O's. That gives me 4 H's. I need 2 there. Okay, now we have 5.0 grams of O2 and 5.00 grams of H2. Okay, change them both into the product. There's only one product, so we're going to go get rid of grams of O2, change it into moles of O2, then change it into moles of H2O, okay, and get rid of moles of O2. Same thing down here. Get rid of grams of H2, change it into moles of H, then get rid of moles of H2, change it into moles of H2O. Okay, and plug in your numbers. 1 mole, 32.00. And remember, mole and mole, you look at the coefficients. In front of H2O, there's a 2. In front of O2, there's nothing, so it's just 1. Okay. 1 mole of H2 weighs 2.016 grams. And look at your numbers. In front of H2, there's 2. In front of H2O, there's 2. Okay. Now, this is going to give me basically 10 over 32, which gives you 0.3125 moles of H2O. Okay. This one here is basically the 2's cancel out, so I'm going to have 5 divided by 2.016, and this will give me 2.48 moles of H2O. Okay, now, which one do you pick? You pick the smaller one. Okay, that means which is the limiting reactant? The limiting reactant is the water. Okay, now what do I need to do? Figure out, answer the question. How many grams of the product will be formed? So 0.3125 moles of my H2O. I need to change it into grams of H2O. Okay, get rid of moles of H2O. Grams to moles, molar mass. 1 mole, 18.02 roughly. Okay, and what's that give you? We should come out with 5.6 grams of H2O. Now, why only 2 sig figs? Go back. Whoops. This said 15. Which means that's not 0.325. Okay, well, let's go back, change this then. This comes out to be 0.9375. 0.9375 times 18.02, that'll give you 16.9 grams. Okay, now notice, why is it still oxygen? This number is still smaller than the 2.48, so it's still the limiting reactant. Okay, now, how do you figure out how much is going to be left over? Okay, take the limiting reactant, change it into the excess reactant, and this basically tells you how much is used up. Okay, so you need to take the original of the excess subtract the amount that is used, and this will tell you the amount remaining. Okay, so our limiting reactant was the 15.0 grams. Change that into moles. Get rid of grams. 1 mole, 32.00. Then change it into moles of the H2. Get rid of moles of the O2. And again, your numbers come from the coefficients. In front of H2, there's a 2. In front of O2, there's just nothing, so it's a 1. Then change it into grams of H2. Okay, and get rid of moles of H2. 1 mole, 2.016. Okay, and you should come out with 1.89 grams. Okay, what is this? Everything cancels out. It's grams of H2. Now, is that your answer? No, this is the amount that is used. Okay, we had 5 grams originally. So, amount left over, 5.00 grams of hydrogen minus 1.89 grams of hydrogen. Okay, that'll tell you how much is left over. And that comes out to be 3.11 grams H2 remaining. Okay, now, last thing we look at, percent yield. Okay, when you run a reaction, you can use stoichiometry and figure out how much you're supposed to get. Okay, so this is what's called the theoretical yield. Okay, this is basically from stoichiometry. Every time you do a problem, you are calculating a theoretical yield. Okay, now, when you actually go and run the reaction, because sometimes you don't always do it as well as you're supposed to, you spill something, you didn't get out all the product when you're trying to weigh it, you don't actually get what you're supposed to get. Okay, so the actual yield, this can only be measured from actually doing the reaction. Okay, you cannot get an actual yield, and the actual yield obviously can vary. If you do it 10 times, you should get 10 actual yields, but the theoretical yield should be the same every time. Okay, sometimes due to errors when you actually do it, the theoretical yield does not equal the actual yield. In most cases, this is usually the case. Okay, so how do you figure out the percent yield? Percent yield, okay, and you may want to write it like this, is equal to the actual yield divided by the theoretical yield times 100%. Okay, now the actual yield, this could actually be larger. Than your theoretical. Why? Simple. Let's say you run a reaction and you get a precipitate, but it's in water. So in order for you to figure out how much product you get, which was just the precipitate, you need to go and dry it off. Okay, so you filter it, you dry it off, then you weigh it. But let's say you didn't weigh off all the water. Okay, so are you actually measuring only your product? No. Okay, so that's why sometimes your theoretical yields could actually be larger than your, or your actual yields could be larger than your theoretical yield. Okay, now when you're doing problems in the book, this will probably be given to you. Okay, or when you do your lab activity, this one you're going to have to measure. Okay, and this is calculated, the theoretical. Okay, so you can try this one on your own. 15 grams of oxygen reacts with 5 grams of hydrogen. Student obtains 15.55 grams of product. What's the percent yield? Okay, we don't have to go and do this whole problem again. This, when they say he obtains, this is the actual yield. Okay, notice you got two quantities here, 15 grams and 5 grams. So it's a limiting reactant problem. But we already did this problem. Okay, and we figured out that the theoretical was equal to, let's go back and take a look at our nice messy screen here, was this one right here, okay, the 16.9 grams that we figured out he should get. Okay, he got 15.5 grams. So what's the percent yield of the reaction? Well, percent yield should equal 15.5 over 16.9. Notice the units cancel out, times 100%. Okay, so that will give you 91.7%. Okay, sometimes you can actually solve for other things. How much product must be collected in a reaction between 25.34%, 25.34 grams of nitrogen and excess hydrogen if the percent yield is 87.34%. Okay, be careful when you use the percent yield. This should be 0.8734, not 87.34. Okay, now how much product is collected? This means you are looking for the actual. Okay, that's X. You need to know the theoretical. So you need to go through and do this problem. Okay, 25.34 grams of nitrogen N2. Okay, and excess hydrogen. So you don't need to worry about what's the limiting reactant. Okay, problem is, what's your product going to be? Well, it's N2 plus H2. Okay, now you guys should know from the last chapter, nitrogen and hydrogen give you ammonia. Okay, so balance this. You need 2 there, and we need 3 there. Okay. Change this into moles of N2. Change that into moles of ammonia, NH3, then change it into grams of NH3. Okay, and this answer right here is going to be your theoretical. Okay, plug it in, solve for X. And your review question. What happens when the limiting reactant is used up?